1 minute, I put charger on. Where I kept the charger? Here. Okay. Just a minute. I'll switch off the light. ಈ ಲೈಟ್ ಆಫ್ ಮಾಡೋದಮ್ಮ, ಈ ಲೈಟ್ ಆಫ್ ಮಾಡೋದು ಕರೆಂಟ್ ಇಲ್ಲ ಅದಕ್ಕೋಸ್ಕರ. ಈಗ ಕಾಣ್ತಲ್ಲ ಈಗ, ಅದು ಮತ್ತೆ ಕರೆಂಟ್ ಹೋದ್ರೆ ಅಷ್ಟ ಅಲ್ವ, ಸ್ವಲ್ಪ ಅದಾದ್ರೆ ಅಷ್ಟು ಎಷ್ಟಾಗ್ತದೆ ಅಷ್ಟು. Voice clear? Is the voice clear? If it is voice is clear, I will start. Okay, I will start. Just one small announcement for everybody. See, I am in my native place now. There is thunderstorm, rain here and lightning also. They are removing power like anything. Today there is no power. I am running by inverter now. Inverter is okay, little power is there. So, and one more thing, because of the severe rain and lightning all, sometime mobile tower problem comes, network problem will come. That is what happened yesterday. Yesterday it was network problem. So, if anything such happens, correctly I will continue next class wherever I stop. I will remember, wherever I stop I will continue, unless what, some important concept is there. If half explained, I re-explain it. Yesterday, fortunately, we correctly concluded one important concept. Then power went. Not power went, network problem. So, charging is on now. But because if power comes, okay. Because here you don't know. It is near Mangalore, so coastal area. Lightning means sometimes you feel difficulty to stand outside. It is so severe lightning here. And rain also, non-stop raining. So one power problem. Second is, that is the network problem comes. You otherwise see, I came earlier and nearly took 1 month time. Not a single class problem was there. So by chance, if anything happens, if class terminates, earlier I will restart once again because one more link I made ready. If it is beyond 1 hour, suppose after 8:30 if some problem comes, I will immediately curtail the class. We'll continue next class. Actually, rain is predicted only for 2 more days. Next week, this problem will not be there. Actually, next Monday, I will be back in Bangalore. Next Monday or Tuesday, most for Tuesday or Wednesday, I will be back in Bangalore. Okay, I will start now. Information for those who are live. Okay, see. Yesterday, we concluded. See, I write here, last class, conclusion. See, if the BM is sagging or if the BM is hogging, anything, this is lengthwise. I told you, see, M, constant BM, M. This is M, this is M. Don't tell clockwise, anti-clockwise. Those who came to my class, by this time you know it. I don't have to tell again and again. Now, red color is not there. Red color is there. Somewhere here, there will be neutral. Somewhere here, it is neutral layer. or neutral plane. It is not axis. See, upper side compression, lower side tension. Here, upper side tension, lower side compression. Okay. Now, across the depth, very important, across the depth for both the cases, if you draw strain variation, how we proved last time that strain due to bending or also called as due to flexion, epsilon, see, strain, not Young's modulus, epsilon anywhere across the time being, I will tell across the depth, which later will be called across the cross section. Later, now we are in the lengthwise view. Cross section we have not gone. Okay, now equal to E, Young's modulus E, not strain, divided by R, radius of curvature of neutral layer. See, if you mark a circle here, the center is here, R, all told, into your Y. Y means from here, either you take Y this way or you take Y this way. This is from the Y is measured from the neutral layer at present. Same thing there. Now, Y. Remember now, I write here now, epsilon anywhere equal to E by R into Y. You require it now. E by R into Y. And Y power 1. Y power 1 means, see, E and R are constant. Why? E is modulus. I think I proved it correct. Yes. I told last time, stress by strain Young's modulus. Yes or no? I forgot. I told or not? Epsilon equal to, no. What we got? I think we got E by R into Y. Yes or no? I forgot. Yesterday word E came. Tell yes or no? The word E came. See, I told strain equal to what? Strain equal to, I don't remember now, because see, we got strain equal to Y d theta. Change in length. Original length equal to R d theta. D theta cancels. No. E has not come. Okay. It will come later. Where this is actually stress equation. Leave it now. Sorry. I am right. Strain Y d theta is the change in length. Whether you take upper side or lower side. Upper side means decrease in length. Lower means increase in length. If it is sagging BM. If it is hogging BM. Upper side tension. It is increase in length. Lower side decrease in length. Whatever it is. Y by R is the strain. Y by R is the strain. Or I told strain equal to 1 by R into Y. Yes. That is where you stopped yesterday. Tell yes or no. We stopped. Video is blurred. 1 minute. No. Video is okay. Video is blurred because you are watching on most probably 144. If you go to 480, it will be clear. Usual problem. See, I will change to 480 now. I will change to 480. It is clear. See, same problem. You are watching it, trying to see the data. When you want to learn something, spend data. Spend the data. Don't bother about data. In front of knowledge, nothing counts. This is, strain equal to 1, we already got last time. 1 by R into Y. Sorry, I will put later. Actually, stress means E will come. Okay. Stress into strain into Young's modulus is stress. Okay, 1 minute. I thought I went advanced now. Okay, leave it now. So, strain equal to Y by R, Y power 1. So, when Y power 1 comes, it is linear variation. So, across depth wise, if I plot the strain variation, see here, I write here, across depth, if I plot the strain variation, this is lengthwise view, neutral layer will be here somewhere, neutral layer, it can be anywhere. Now, see, we got strain anywhere equal to what? 1 by r into y. That clearly means strain due to bending, which you can see lengthwise. When you go to cross section, you have everything, strain and stress, both are perpendicular to the cross section, repeatedly told. So, therefore, lengthwise you can see a strain. See here, you can see strain. Therefore, y power 1 linear variation. Now tell me, as y increases, 1 minute now, when y equal to 0, you are at where? Same argument for stress also later. I want once again tell. When y becomes 0, you are where? Tell me. When y equal to 0, from neutral layer, neither go up nor come down. Where you are? When y equal to 0, where you are? When y equal to 0, where you are? See, this class I will tell in full detail. Let it take 10 class for derivation, no problem. Once you struggle and understand, concept will be clear. Hurry, I can finish in half an hour only if you want. No, video is not blur. That is your network problem. I can see here. It is crystal clear. No, it is your network problem. That is sure. It is surely your network problem. Because I can see here. It can be clear for me and not clear for you. Even in this mobile, I can see clarity. Okay, 720, go it. Now tell me, when you put y equal to 0, tell where you are. This I will not tell again for stress. When you put y equal to 0, where you are? Fast. I am talking lengthwise. When y becomes 0, where you are? Where you are means which element, which fiber you are considering. See? No answer. If you put y equal to 0 means you neither go up nor come down. Where you are? See, if reply not comes, what happens is doubt comes to me. Is audible or not audible? Then I will take a class for half an hour, then tell not audible, I will once again take the class. So your reply is important. The purpose of question is two reasons. One, to get convinced that you are understanding. Second one, audio is clear. Okay. Neutral plane. When you are in the neutral plane, see, by name only, neutral. No compression, no tension. So remember, when y becomes 0, strain also becomes 0. And as y increases, color, don't worry. As y, see, red color I will put here if you want. As y increases, what will happen? Epsilon equal to 1 by r is constant. Why? R is the radius of curvature of neutral layer. For a circular arc, radius is constant. Therefore, as y increases, what will happen? Your strain epsilon also, what? When y increases, strain epsilon also, what will happen? As y increases, either side, whether you go up or come down from neutral layer, as y increases, strain also will, see, linearly proportional. You can make out here, y increases, strain also increases. So, how variation? Linear variation we prove. Therefore, see, from here, as you increase y, strain will keep on increasing. I will do one thing now. One side compression, if I plot that side, tension, I will plot this side. Same line. See, same line, I will put this side, tension. Now, that way, when you put, see now, suppose imagine from here to extreme fiber here is y1, to extreme fiber here is y2. So, when your y becomes, see, I will put here now, y1, y2, extreme fibers, y1, y2. So, in my class, y1 stands for no compression tension, top extreme fiber distance from neutral plane. y2 stands for bottom extreme fiber distance from neutral plane. So, when y becomes increases. So, when y becomes y1, as per this sketch, epsilon will be maximum in compression. And when y becomes y2, the strain will be again maximum in tension. So this will be epsilon maximum in compression, already written here. This is epsilon maximum in compression. This is epsilon maximum in tension. Whereas if it is hogging beam, I will plot compression that side. See, this will be tension. This will be compression. This will be epsilon maximum in tension. This will be epsilon maximum in compression. Tell me, linear variation. Fully clear? Fast. Full clear or not? If video bar for 480, go for higher only. Actually, okay, I can make out. That is, oh yes, maybe you have to go for a little higher. What to do? Once in a while it happens. If I go to 720, my data will be closed. I should be careful. Because there is no Wi-Fi here, please. No power, no Wi-Fi. Complete depending on mobile data only. If mobile data gone means, that mobile reserve data is there. But this mobile, limited. This is dummy mobile. I cannot go above 480. Okay. Now, therefore, this is the strain variation. Now start. Now yesterday, at the end of the class, when class got cut or stopped, I told you, so far, we never discussed elastic theory. See, we never discussed elastic theory. Therefore, whether it is within elastic limit or beyond elastic limit, technically, whether within proportionality limit or beyond proportionality limit, it hardly matters. Strain variation is always linear. See, but little later I will tell you, if you consider within elastic limit, actually within proportionality limit, both are nearby, then stress is proportional to strain. So then strain linear means stress also linear. That's why I told yesterday, in working stress method, strain linear variation across the depth and stress also linear across the depth. See, RCC, stress and strain both we write linear. See, in RCC, stress linear, strain also linear. Strain linear, stress also linear. But in limit state method, even in limit state method, strain is always linear. There, strain linear, no doubt, but stress is not linear. See, that is I told. In RCC, who takes limit state method, he will tell you, we know that strain variation is linear always, irrespective of working stress method or limit state method, but stress variation with respect to strain will not be linear beyond the limit. So, in limit state method, stress is not linear, strain linear. I told last time, I watched the video there, suddenly it went out. Now clear? You can make a note. All those concepts clear? Okay, hope it is clear now. Okay, start. Now, go a little further. Now see, I will remove all this one now. Strain equal to 1 by R into Y. Remember, strain we got. Then, we want stress. When strain is there, there is stress due to bending. Due to bending. Symbol for stress, I told I will take sigma for YouTube class. When I come back to your Zoom later in BSK class, I will take once again the IS code symbol, stress F only. Why? Because I told the reason for you. Because IS code stresses are called by F. So that no problem. See, bending stress up to a certain limit I will cover here. More and more finer points are there. That I will not I will discuss maximum possible in YouTube. But there are very, very delicate matters are there that it requires a lot of conversation. I have to talk in odd way. I have to keep on trapping you. So YouTube, I do not want people to comment, this person only traps. So I do not want it. So I will leave YouTube then and go back once again to Zoom. That is, our BSK will continue. I will tell goodbye in YouTube. What I told is sufficient for you, I will tell. Suppose anybody tells, I want further knowledge, okay, get it yourself only. From my side, that's all. But more classes are there. I will cover maximum possible. Okay, start. Stress. Sigma. You know that now in the basic bending theory, there is one assumption. The strain and stress both are within proportionality limit. So, write clearly or write this one. What all statement I write, if you write everything, you understand. Therefore, up to proportionality limit, you can tell stress is proportional to strain, or I am wasting my time. You know, stress sigma in bending equal to a constant into strain epsilon. Tell what is the name of that constant which relates stress with the strain longitudinally. The constant, material constant, which what? Which relates stress with the strain. Okay, maybe mobile not clear. No power here also. See, same problem here also. I hope at least now, 1 minute now. It is clear, I think. I hope at least. Clear. Okay, no problem. Later you can watch, no problem. Young's modulus of elasticity E. Capital E means Young's, remember, this is strain epsilon. This is E over. Young's modulus sufficient. Why? When I am in the bending stress. My class is for BSK batch. Already told earlier, stress proportional to strain, stress equal to strain into Young's modulus. Thousands of times told. Those who are newcomers, you should know it. Stress by, see, you can remember this way. Stress divided by strain equal to Young's modulus. So stress equal to strain into Young's modulus. Therefore, I will remove this one now. Therefore, intensity of bending stress are called flexural stress. You write sigma anywhere at y from neutral plane equal to what? Epsilon equal to 1 by r into y into e. Or I will write here, anywhere across cross section, anywhere across depth at present, because still I have not talked about cross section. Anywhere across depth, stress due to bending, it can be tension or it can be what? It is compression on one side and tension on other side. This much not required. Sigma equal to what? E by R into Y. This is the relation. Stress sigma equal to E by R into Y. Now, this again shows that, now E is constant, R is constant, or E by R is constant. Therefore, stress also is proportional to distance from neutral layer, or the way I told stress, which one? The way I told for strain, same way stress variation also linear. When y, you write, when y equal to 0, sigma equal to 0. When y equal to y1, sigma is maximum at the top fiber, and when y equal to y2, sigma is maximum at the bottom fiber. If it is sagging BM, then what? Then this is sigma compression maximum. Okay, write neatly. Then the top is sigma max in compression. Here, sigma max in tension if the BM is sagging, or if the BM is sagging. If the BM is hogging, then here sigma, if the BM is hogging, top tension, sigma max in tension, here sigma max in compression, variation this way. This is the along the neutral. This much statement clear. Yesterday, if there was no problem, I would have finished all this one and we would have been about to enter cross section. This much clear? Yes, E into Y by R only I wrote. E into Y by R, correct. You will write E by R into Y. Clear now? E by R into Y, correct. Both are same. Hope this is clear. Everything clear? See, just to confirm voice clarity, I am asking clear. In my class, such concept when explained, it should be clear. I always tell you, someone will tell Kannadadalli, ahankara anta. No, arrogance. He tells, whatever he tells is clear, he thinks that way. Yes, I think that way. I know it. Whatever I tell is always clear. There is absolutely no doubts for anybody if they correctly follow. Okay, now, one small important, see, therefore, I will do one thing now. See, this is required further. Required further. Or you can tell, see, sigma by y, sorry, sigma by y equal to E by R. This I will call equation number 1. Tell why? Because to go to basic bending theory, you need what? You need M by I equal to sigma by y equal to E by R. Unfortunately, suddenly heavy rain, but Bangalore means problem, sheet. Here not that way. Rain okay, I can manage. Voice will be clear. I told you, I do not worry about that shoki or show off like that. I do not want any disturbance like that. Okay, now, with this one, lengthwise part is over. See now, what you are doing is very powerful. I will explain complete concept for you. Consider cross section. Right now, consider cross section. That is the most powerful term in structural engineering. Yes or no? Consider cross section. That is the most powerful term in structural engineering. Are you agreeing? The most powerful term. So many people don't understand what is it important. It is the number one term in structural engineering. Okay, start. Consider cross section. I will randomly put the cross section. Imagine this way. But one thing, I should maintain symmetry about YY axis. See, now, there is an axis here. Remember, this is, see, I already showed you, cross section. You can see one axis widthwise. See, this is widthwise axis. Neutral layer is lengthwise. Cross section, you can see widthwise. This is the axis, or this is the line of intersection of neutral plane with the cross section. This is called neutral axis. See, this is called neutral axis. All those who tell neutral axis lengthwise, it is complete nonsense. Neutral axis comes in the cross section, because when you apply bending moment is always about this axis. See here, see, you cannot show bending moment here. Now bending moment is like this. Beam is like this, BM like this. When you take cross section, see, one hand behind, one hand in front. This is the bending moment. This is compression. This is tension. You cannot see. And this is compressive strain. This is tensile strain. The strain, stress, both are normal to cross section. You write yourself only. Normal to cross section. Which one? Both strain and stress. Normal to cross section. We cannot show. Actually, diagram you have to write here. Here I cannot write. I will turn it and write. So later, if I write the diagram like this, remember, if I put an arrow mark here, it means what? If I put tension, I put this way. Suppose I put this way to show tension. If I put arrow mark like this, it is this way. Lengthwise you can see it. See, compression and tension, lengthwise you can see. Cross section you cannot see. That's all. Now I will not talk about this one. Why? I told enough number of times. Clear or not? Fast. Remember now, even bending moment you cannot see. See here. Cross beam, if the beam runs this way, BM is this way. When you see cross section, you cannot see it. It is this way. See, if it is sagging BM, M here, see, it will hit this one, compression. It will pull this one, tension. See here. If I apply this way, that side is compressed, this side is pulled. See, foundation problem I told you. Remember, if the moment is like this side lifting, this side pressing. Remember or not? I told in the footing pressure. Tell yes or no. In the footing pressure, I told this one. Tell yes or no. While finding footing pressure, RCC class, I told this one. Okay. Now, what is more important is, see, why we consider cross section. Reason. Those who want right, I will tell only once. Sigma by y equal to E by R. R you can see it is a property what? You can see lengthwise. That's why front view. Same in torsion also if remember. And now you are, this all due to, everything it is due to bending moment M, which can be sagging or hogging, anything. Bending moment M. Now, I repeatedly told class after class, year after year, that loads are not resisted by beam. All nonsense statements. Beam is required to resist the load. Beams are not resisting the load. Fully gone. Every structural member will receive the load and transfer. Because of this effect or during this process, cross section is subjected to section forces. One, axial force, long back over, shear force will come later, bending moment, later twisting moment. All those axial force or shear force or bending moment or twisting moment, write once again, are all resisted by what? I am not writing fully. You should write yourself only. All those section forces, axial force, shear force, bending moment or twisting moment, all of them are resisted by what? Resisted by whom? By cross section. Now, I will show you how it is resisted. See, I will show it to you how it is resisted. 1 minute. See, now, neutral axis, come this side. I tell neutral axis, hey, don't go there. You write here. Space is not there. Okay. Now, what you do is, in the cross section, remember, this is the neutral axis. Remember now, the bending moment M is about this axis. See? See? Because of that one, specs only gone. Okay, okay. Hope if I fell down, problem would have come. Maybe it is telling, don't tell you, it is warning me, the specs. You told about the axis thousands of times for them. This way means this is the axis. 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 Why are you telling? Okay, leave it. Now, this is the axis about which bending moment. That's why in STAD Pro, bending moment is called MZ. In STAD Pro, this is Z axis, local. In ETAP, it is M3. This I will tell in the respective class. Why it is M3 in ETAPs, why it is MZ in STAD, and shear force is reverse. See, in STAD, bending moment is MZ, shear force is VY. In ETAPs, bending moment is M3, shear force is V2, because shear force is along, bending moment is about. Sorry, respective software class, not now. Okay, now, see, I cannot show bending moment here. It is like this. Now I will do one thing. I will see the beam. See here. Imagine the beam is like this. Just imagine. Beam is like this. Any beam. Imagine this is our cross section. Remember, if I take out, I put black color. This is cross section. This is the neutral layer. See, now from this side, you remove this side. You remove this side, equivalently you apply a bending moment M like this, sagging M. Now tell me, if you apply BM this way, it will go and compress this one and it will pull this side, correct? It will compress. Therefore, in the cross section, resistance will come. How? It won't come uniformly. Resistance will come like this. See, I'll show you. Resistance will come this way. Why spread? Because you know that bending stress is linear. So now, because of all, see, this M will this way. See, this way, upper side is compressed, lower side is pulled. Now I'll remove this one now. Now it will have, this is the stress variation, compression, and this is compression, this is tension. Now because of this one, there will be a resultant compression force C. Because of this one, there will be a resultant tension force T. Where it is acting, we will see later. And anybody knows there is a name. Actually, if it is uniform width is there, this will be 1/3, this is 1/3. That all we will discuss later. It is not center. See, now between these two, there is a distance. Distance between line of action of resultant compression and line of action of resultant tension. Anybody can tell me what is the name for this one? Some people, when they find moment, I don't want to comment. When they want moment, they use this word. I will tell them, sorry, there it is called something else. You are having wrong concept. He may not listen to me. One fine day he may listen to me, helpless. Lever arm. This is called lever arm. See, when you find moment, that is called arm of the couple. It is arm. It is not lever arm. Lever arm you usually use when internal resistance comes. Clear now? When you come to my class, stick to my principles. Try to find one mistake. It is called lever arm. Okay, now say lever arm is A. Now tell me, for equilibrium, the C will be equal to T. Why? No horizontal resultant force acting. See, this is all internal forces. When there is no external horizontal forces, for equilibrium, these two should balance each other. So C will be equal to T. When C equal to T, this will form what? These are two equal unlike parallel forces. Two equal unlike parallel forces will produce or result in what? Two equal unlike parallel forces will result in. No, it is still clear. Cannot see properly, sir. Why? Maybe network problem, correct? All because of network problem. But 1 minute now. I will check it here. If I can see, no problem. You can see it later. Nothing to worry. If I can, 1 minute now. I think some little tapping required. 1 minute. Hope there is no problem here. Luckily, no problem. No, clear. Nothing to worry. You can see later. Little. It is actually clear in the mobile. That means no problem. Okay. In case later, if I find, if it is not clear, I will not what? Delete this video. What I will do is, I will prepare a recorded video supplement to class number 3. I will tell in class number 3, some of the sketches are if not clear, I will explain in the board, but I will tell you, audio part you should listen there. Explanation I won't tell because I don't remember. If you ask me to take the class once again, I will start some other way. I will not talk this way. I never took two identical classes same way. That is called by hearting and coming to the class. So that way, I think it is 1 minute. I will try higher power. 480. I will go to little advanced and try. 725 try. 1 minute. Yes, in my mobile also, little blur. But there it is fully clear. That is the problem. There you can't tell because it is a display there. Everything depends here only. One minute. I cannot refresh here. Now 1 minute. Is the problem of not clarity? Video not clear, not audio. Is it for everybody or some are able to see clearly? If some are able to see clearly, later when network problem is there, you can see clearly. Is at least some of you are able to see clearly? Tell me. If some of you are able to see clearly, listen to the voice. Later it will be clear. No sir means I can't make out. Only video problem. What to do for this one? Video is blur. 1 minute. I'll try once again. I'll tap here. But here it is okay because this is a display video. This will be always clear. Again network problem I think. Because of network only. I think now it is suddenly better. See, now suddenly I can see little more clarity. Suddenly I can see little now clear. Okay, thank you. Okay, suddenly clear. Okay. But remember, even if it is not clear, blurring is there. What I tell you, make out. No diagram you can make out. What I explain is more important. Here, right now, that explanation is more important, not the sketches. Sketches you can see here. Worst come worst, I will prepare one more class, recorded class and update, supplement to class number 3. I will watch later. Tomorrow I will watch later. If I feel some of the writing is not clear, I will give supplementary, maybe 20 minutes class, not much. Only sketches I had explained. I don't have to tell all these things. Statements all you refer to the class. Clear now? No problem? Now clear? Okay. No, now clear. I can see clarity now. Now not clear only because of your network problem. See, now crystal clear. I can see now. Now it is crystal clear. Okay. Nothing to worry. Okay, start. It is called liver arm. But keep answering. Liver arm. Now, this will see, if you apply a BM this way, see, it will try to rotate like this, and for balancing it you require opposite couple. So see now, this will form a resisting couple like this. M resisting. This is bending moment. People call this is external. For the cross section, this is external. So many people, they tell axial force, shear force, bending moment, shear twisting moment are all internal. I feel pity for their knowledge. They will tell a column you take, apply a load on the column, they will tell axial load is internal. What is this first of all? You take a member, see, you take a member, apply a couple, tell me, you apply a couple this way, or take a member and you twist it like this. Is the twisting moment or bending moment or axial force, is it external or internal? Tell correctly. This is where so many ignorant people, they think that some are highlighting so much that they will tell you, remember, these are all internal. If I am there in front of them, I will tell nothing doing. Tell me, internal or external? All the section forces are internal or external? Tell me, They are no, section forces are what? Section forces are axial force, shear force, bending moment, twisting moment. They are internal or external. They are internal or external. They are internal. Ayo, what happened? You also going to their party. I am telling external. You are telling internal. Then what is external then? Internal resisted by internal law. See, they are external. And remember, external action. This is internal reaction. This is M, external. This is internal resisting couple developed due to what forces because of stresses, which is because of strain, which is because of external bending momentum. See, all those people who shout bending moment is internal, same person, I saw him telling RCC class, see, external bending moment is internally called moment of resistance. He forgot completely that earlier he was shouting internal. Suddenly I heard him telling, see, the external bending moment is resisted by internal resisting couple, that is called moment of resistance. Then I will tell him what you told earlier. Okay, leave it. Why should I bother about others? If they listen to the class, they will change their attitude. Okay, now, for equilibrium, this resisting couple should be equal to M. Yes or no? The resisting couple, moment resisted internally, that should be equal to M. Clear? Light making low is problem I can make tomorrow because I shifted from upstairs to downstairs. Nobody in the house. Light will change tomorrow. Today, okay, one day. Or I will try to reduce the glare little. I don't know. Is it okay now? Tell me. Is it okay now? Is it okay now? Tell me. Is it okay? Or one light I will remove. No. Is it okay now? Is the glaring lesser now? First. Contrast I changed. Okay. No, tomorrow, because from upstairs I shifted because nobody in the house. I had to look after my mother here. So that's why I want to be nearby only. Okay, start. Now, see, this is this way, that is this way. So, if this is clockwise, that is anti-clockwise. Correct. That is direction based. Nature, see, clockwise applied moment is resisted by anti-clockwise resisting moment. But if you see bending moment, this is sagging. What is that one? Tell me. This is sagging. What is that one? Tell first. This is sagging. What is that one? What is that one? If this is sagging, what is that one? First, that also sagging. I sometimes try to trap the students. I will tell them, see, right side force, see, I will tell that way. Very beautifully I can trap. Right side force balanced by, tell me answer, left side force. Good. Downward force balanced by upward force. Very good. Then I will tell them, see, clockwise couple balanced by, sir, anti-clockwise. Very good. Correct. They are all direction based. Then I will tell them, what? Compression balanced by, they will tell tension. Wrong. Compression is balanced by compression only. Sagging is balanced by sagging only, not hogging. It is nonsense. Direction based balancing is opposite. Nature based nature is same. Compression balanced by compression. Tension balanced by tension. Sagging balanced by sagging. Hogging balanced by hogging. But direction based, clockwise balanced by anti-clockwise. There see, I don't tell sagging hogging. Right side force balanced by left side force. I don't tell compression tension. Clear? At least you should not fall trap for such things. Clear now? Don't fall trap except in front of me. Except in front of me, anywhere, don't get into a trap. Oh, agreed? In front of me, okay. Because I am what? I am a born trapper. My every class, here online you can't see much. Offline class I do that one. Only trapping. Why? Purpose is to educate and give more knowledge, not for enjoyment. Okay, start. Now, this is clear now. Now do one thing. I want expression for MR. So, if you want to understand, and now remember now, this MR is equal to M. I told you already. Now, this is lengthwise. If you see cross section, that MRI shown will come like this. This way. So, side by side, right, I told already, one side compression, one side tension, or come this side. Okay. One resultant force here, one resultant force here, means it is not that way, it is this way. This will form a couple here, resisting couple MR. See, it actually comes this how. If I take this way, if the applied BM is this way, resisting will come this way. This is all I told. Now I want expression. So, when you want expression for internal resisting moment, you should not consider lengthwise view. Tell what you have to do. When you want any resisting effect, section for resistance, you should consider what? Not lengthwise. When you want resistance from the inside, you want to consider what? When you want to find the resisting effect or resisting power, you have to consider not lengthwise. What you have to consider? For understanding the resistance, what you have to consider? What you have to consider? Front view or cross section? Front view or cross section? For resistance, cross section, or I told thousands of times, bending moment, shearing force, axial force, twisting moment, all resisted by cross section. Start. Now, what you do is, you take a elementary strip here, very, very small. See, small strip. Remember now, for entire strip, your Y is constant. Correct? Your Y is constant. Very important. You cannot take a strip like this. No. You should take a strip so that Y is constant. Now, let the strip area equal to dA. This thickness is called dx, not required. Okay, take it. This thickness is called, no dy. Leave it now. We don't require thickness. Later you require, or you tell this is y, this is dy. You can, but actually, right, y dy, I am removing it now. Area is dA. This cross-sectional area is dA. For this one, force acts, stress acts this way. Okay, start. Now, we know that, see, at this level, for elemental strip of area equal to dA, tell what is the stress due to bending. Sigma equal to, see, we know it is E by R into Y. Clear? First, it is E by R into Y, already proved. E by R into Y. Clear means I will go further. I am asking clear only for one reason. Why one reason? Just to see that it is audible. This should be clear. Just for confirming it is audible. Because of network problem all. If it is clear, okay, clear. Now, this is stress. Therefore, see, if this is stress, therefore, force in the strip, in the elemental strip, force in the elemental strip, that is called sigma over, I will call dF. Why dF? Very, very small force. You know that force equal to stress into area. If what? Stress is uniform. Yes, stress is uniform. Why? With such a small area equal to sigma into dA. Thank you. Someone already wrote there. Who wrote? Someone I wrote. Yes, stress into area. Before that, someone wrote. Thank you very much. ಫೋರ್ಸ್ ಇಂಟು ಏರಿಯಾ. ಅಯ್ಯಯ್ಯೋ, ಫೋರ್ಸ್ ಇಂಟು ಏರಿಯಾನ ಹಿಂದೆ ಮುಂದೆ ಆಗೋಯ್ತಾ? ಸ್ಟ್ರೆಸ್ ಇಂಟು ಏರಿಯಾ, ಕನ್ಫ್ಯೂಷನ್ ಆಗೋಯ್ತು. ಫೋರ್ಸ್ ಈಕ್ವಲ್ ಟು ಸ್ಟ್ರೆಸ್ ಇಂಟು ಏರಿಯಾ ಈಕ್ವಲ್ ಟು ಎಷ್ಟು? E/R into Y into dA is the elemental force. Now this is dF. Now start. Remember, now I will write here dF equal to force in elemental in the strip, elemental strip equal to E/R. I will interchange into dA into Y. Actually E/R/Y into dA interchange, E/R dA into Y, that is the force. Okay, I will do one thing now. See, in the next class I want to discuss once again here. Next class I will tell some concept. We want to know where is the neutral axis. I think all are knowing. For neutral axis always passes through what? Almost all are knowing. Neutral axis always passes through. Neutral axis always passes through. You know it. Neutral axis always passes through. Past. Wait out. Centroidal passes through CG of the cross section, correct? Or neutral axis is also centroidal axis, but we have to prove it. For proving that one, I need this equation once again tomorrow. Tomorrow I will tell you. Today I will not tell you. Tomorrow I will tell you. You should. Somebody will ask, how you got it? Leave my class. See, my usual question. Somewhat arrogant. Leave my class. Why? Suddenly came today without going to previous classes. My class is not for you. Okay, now this is dF. Now I want to find resisting moment. See, I remove this one now. Okay, it is answered. Here only there dF. Okay, now moment of this force dF in elemental strip. Tell me about what? Tell me about. Now you know that this is compression, this is tension. One resultant compression will come, resultant tension will come. Now you know it will form a couple. I want to moment of that couple. To get a moment of the couple, tell me, you should take, see, 1 minute, see, important concept. If there is a force of 10 here, I will tell now only, suppose by chance any problem comes, if power problem comes, any problem comes, no problem, I will remember, I will tell tomorrow. See, I wrote this equation. See, just to make a note, this is what so many are getting confused. Suppose there is a force of 10, another force of 10 here, distance is 4. Tell me, moment of this couple is, answer, moment of the couple we usually define how? Equal to any one of the force into perpendicular distance between the forces, between the two equal unlike parallel forces. So answer is 10 into 4. Correct or not? 10 into 4. Yes or no? 40. Now remember, time being, you consider direction. Right here, no bending moment. Imagine you are in engineering mechanics. So in engineering mechanics, you do not know bending moment. Actually, I was also not knowing at that time. Later, when I came to bending moment, I studied it. Okay, you can think that way. Okay, 10 into 4. Tell me, which 10? This 10 or this 10? First. That single right 10 or double right 10? Which one? Single right 10 or double right 10? First. Which 10? Any one. So this 10 is any single right 10 or double right 10. Over. I will ask a question. Suppose this is 10, this is not 10, it is 12. what to take. Some will tell, sir, take the least value. Some will tell, sir, take the average value. My answer will be, if it is not 10 and 10, if it is 10 and 12, it is not a couple. It is not a couple. It is not two equal forces. What you are telling answer? If you want a couple, those two forces should be equal and opposite. See, resultant compression equal to resultant tension. RCC you write 0.36 FCK into B into X equal to 0.87 F.AST. Heard of it? 0.36 FCK into B into XU, resultant compression, equal to 0.87 F.AST. Or doubly, 0. FCK into B into XU plus FSCASC, that is compression, equal to 0.87 F.AST. Therefore, both are equal. See, in RCC, remember, you write MR equal to either C into A or T into A. We don't add it. Okay, now, so it is 40 is the answer. Tell the direction. Okay, this time direction allowed because I am in engineering mechanics. Direction. If I take moment about this point, 10 into 4 anti-clockwise. If I take moment about this point, 10 into 4, oh, anti-clockwise, or it is anti-clockwise 40. Tell yes or no, fast. Anti-clockwise 40. Now, is it compulsory that to get moment of the couple, see, if you take moment about this point, it is that force into arm. Or if I take moment about this point, it is this force into arm. Or moment of a couple is any one of the force into distance between them. So tell me, is it compulsory to take moment about either this point or this point? Tell the answer. Is it compulsory or not compulsory? First. Someone told in the YouTube class, it is compulsory. Then I will tell him, then how you derived basic bending equation? There what you have done? Tell me, is it compulsory or not compulsory? First, when you find moment of a couple, is it compulsory that you should take moment about one of the force? Is it compulsory? First. Answer. Is it compulsory? See, concept means concept. So many will tell, his class is so lengthy, don't come to my class. I am updating this class for knowledge purpose, not for your time pass purpose. No, sorry. It is not compulsory. Who told? It is not compulsory. Someone with a high level, he told that way in engineering mechanics class. I don't want to tell who. With lakhs of views there. Beautiful setting, very beautiful printout, everything beautiful. He told clearly, it is important that you have take moment about this point, moment about this point. If he comes in front of me, I will ask you, then how you derived basic bending equation? He will tell, oh, sorry. He will tell, sorry. You can take moment about any point. You take an outside point here or inside point. See here. You can take moment about any point. See, either here or here or here or here or here. See one thing. Take here. 3 extra. Take here. 2 extra. Take here. 1.8 and 2.2. Now see the answer. Take moment about this point. Start. 10 into 3 is clockwise. Clockwise. And another 10 into 7 anti-clockwise. Tell the answer. 10 into 3 is 30 clockwise plus 10 into 7 is 70 anti-clockwise. Answer first. Answer. 40 anti-clockwise. Okay, 40 anti-clockwise. Take moment about this point. Answer. 10 into 4 plus 2, 6. 10 into 6 anti-clockwise plus 10 into 2 clockwise. This is 60 anti-clockwise plus 20 clockwise. Answer. First. 60 anti-clockwise. You can type the answer without seeing anywhere. 40 anti-clockwise. Or take moment about this point. It is 10 into 1.8 anti-clockwise and also 10 into 2.2, that also are anti-clockwise. Add it first. Add it. Answer. Add it. Answer. 40 anti-clockwise. Therefore, when you want to find the moment of a couple, you can consider any point in the plane. There is no rule that you should take this point or this point. This point and this point you take for convenience. Instead of struggling this way, why confusion? See, any one of the fours in distance means if you take this 10 into 4, you are taking moment about this point. If you take this 10 into 4, you are taking moment about this point. Or, moment of a couple about any point is constant. Yes or no? Moment of a couple about any point is constant. That's why in a beam, if a couple 20 is given, when you take moment about this point, you write 20 only. About this point also, 20 only. About anywhere you take moment, you write 20 only. Into is not there. Now clear? So when you want moment, you can take moment about any point. No restriction. Yes, it is one of the characteristics of the couple. Yes, correct. And if in engineering mechanics for your BSK batch, I proved it. Okay. Why I tell? Because some people tell. See now. Okay, leave it now. We will come to concluding part of this one. Time. Okay, no problem. I can conclude now. Now, okay, all gone. Now we know force is here. Therefore, moment of this force dF take about neutral axis. That is, you can take about neutral axis equal to dF into what? The force is like this. You cannot see here. If this is clockwise, this also, this clockwise only. See, dF into what? Distance first. dF into moment of that force dF about neutral axis equal to dF into. Any problem? Oh, luckily. Okay. dF to y. Okay, thank you. dF into y is the moment. Okay, equal to dF equal to E by R into what? dA into y into y. See, this is dF, or equal to E by R constant into dA into y square. This is moment of this dF about neutral axis. dF is what? If you considering what? Considering elemental strip. That is the moment. I will call this as dm. Why dm? It is due to elemental strip, dm. Now, therefore, algebraic sum of all such moment, one strip there, one strip here, 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 there, everywhere. Algebraic sum of all such moments, that is equal to sigma of E by R into dA into y square, or I can write that as algebraic sum of moments of all such forces. Oh, gone. The pen cap gone. I cannot leave it because without pen cap it is very difficult. Another 2-3 minutes means the pen will stop writing. Okay. Equal to, right here, algebraic sum of all such internal moments due to internal resisting forces, that is equal to sigma of, I told you, E by R dy square. Your E by R is constant. E by R into sigma into dA into y square. Remember, right? This is the internal resisting moment. Why? Internal resisting moment, because of the stresses acting on the different tips, internal resisting moment, and this will what? Balance that external bending moment M, on this will be equal to M. How much is the action, that much is the reaction. How you pay somebody 100 rupees, he should give back 100 rupees, interest not counted. See, in structure engineering, there is no interest. Pay 100 rupees, take back 100 rupees. Don't tell tomorrow, give 10 rupees more. No, interest is not counted. Only what? Transaction original values. Okay, now this is M, or remember, this is the internal resisting moment which is actually balancing that external bending moment M, or you can tell M equal to E by R into sigma of dA into y square. Now, very, very sorry, those who came to my BSK class from beginning, if they don't tell the answer, I will stop my class today. From tomorrow, I will block all those people who came to BSK class if you don't give the answer for this term. Whereas, general public, if you don't give the answer, what I tell, you believe. I am quite dependable. You ask anybody, whatever he tells, can we believe? You try to ask a question, see what people will tell. Therefore, those who are newcomers, YouTube viewers, you believe what I tell. First of all, when you come to my class, you have to believe whatever I tell. That's all. No other way for you. But those who are studied under me in basic structural knowledge, if you don't tell the answer, for them tomorrow I am blocking. Answer came, I think. Oh, answer came. Thank you. It is moment of inertia of cross section about which axis? Tell me. About the axis in the cross section about which bending will be applied. Which axis? Don't tell x-axis centroidal. We still not proved that this axis is centroidal axis. About. When you tell moment of inertia, you have to always tell axis. Which axis? Tell me. Which axis? We did not still prove it. It is new. By chance I was about to tell the answer. Which axis? Axis first. You tell the axis, I will conclude the class then. You tell, if you tell only I, not clear. I about which axis? Moment of inertia of the cross section about. Are you not hearing? Oh, looks like some network problem. No. No. You are not answering. After, I am not going to block you. Just for fun I told. Do you think I will block? I only threaten that way. I don't block. In the college, someone will tell, tomorrow if you don't answer it, I am not taking your class. They know that I am coming. About which axis? First. You tell me about which axis. There is a name, at present there is a name for the axis. At present there is a name for the axis. Like time problem. Not next though. Okay. Okay, I'll do one thing now. I will conclude the class. If it is not audible, I will tell once again tomorrow. It is moment of about the neutral axis. Neutral axis, which we will prove tomorrow that it will pass through CG of the cross section, or it is also called as centroidal axis. Symbol is simply INA. Therefore, M divided by, therefore you can tell M equal to E by R into I about NA, or you can tell M, you tell it, come this side, M by INA equal to E by R. 1 minute, Remove the volume there. E by R, or this is called equation number 2, this is called equation number 1. From 1 and 2, tomorrow I will discuss. See, from 1 and 2, you can write M by INA equal to sigma by Y equal to, come here, E by R. This is called basic bending equation. Net problem is there. Luckily, up to 9 o'clock we survived. Okay, we will continue tomorrow. Today I am closing the class. Luckily, if the ending part, if any clarification required, tomorrow once again I will give you. Okay, thank you. ಮಾಡೇ ಬಂದಿದ್ದ ಕಾಲ್ ಮಾಡಿದ್ರೆ